Welcome to Lesson 2 of Focal Area 2. In Lesson 1 of Focal Area 2, we learn about the 6 components of a scientific project and the 10 steps of project design. We learn that the research question and hypothesis are the foundation of your project. In this lesson, we are going to dive deep into those 2 components. We are going to learn how to ask good research questions and how to formulate testable hypotheses. By the end of this lesson, you will be able to write clear, specific research questions that are answerable through investigation. You will also be able to write testable hypotheses that make predictions based on existing knowledge. These skills are absolutely crucial for designing a good scientific project. So let's get started. Let me start by asking you, what makes a good research question? Well, a good research question has several characteristics. First, it is specific and clear. That means you should be able to understand it easily, and it should focus on one main idea. Second, it is answerable through investigation. That means you should be able to test it by doing an experiment or making observations. You shouldn't ask a question that can only be answered by reading a book or asking an expert. Third, it is testable with available resources. That means you should be able to answer the question using the materials and equipment you have access to. You shouldn't ask a question that requires expensive equipment or resources you can get. Fourth, it is not too broad or too narrow. If your question is too broad, like how do plants grow, you won't know where to start. If your question is too narrow, like what is the exact height of this specific plant, you won't learn much. You want a question that is just right. So, how do you write a good research question? Start with does, how, or what. These words help you ask questions that are answerable through investigation. Include what you change, the independent variable. Include what you measure, the dependent variable. For example, does the amount of sunlight affect plant growth? This question starts with does. It includes what you change, that is the amount of sunlight. It includes what you measure, that is plant growth. It is specific, answerable, testable with available resources, and not too broad or too narrow. This is a good research question. Let me show you some examples of good and poor research questions. So you can see the difference. Here are some good questions. Does the amount of sunlight affect plant growth? This is good because it is specific. It focuses on sunlight and plant growth. It is answerable through investigation. That means you can set up plants with different amount of sunlight and measure their growth. It is testable with available resources, which means you can do this in a classroom or at home. It's not too broad or too narrow. How does temperature affect sugar dissolving? This is good for the same reasons. How does exercise duration affect heart rate? This is good because you can measure heart rate before and after different amounts of exercise. And does soil type affect water drainage? This is good because you can test different soil types and measure how quickly water drains through them. Now, let me show you some poor questions. Do plants grow? This is too vague. It doesn't tell you what you are investigating. Are you investigating how fast plants grow? What makes plants grow? How much do plants grow? You need to be more specific. What affects dissolving? This is too broad. There are hundreds of things that could affect dissolving, which include temperature, the type of substance, the amount of stirring, the type of liquid, and so on. You need to narrow it down to one specific thing. How does everything affect plants? This is way too broad. You can't investigate everything. You need to focus on one specific thing. Do you see the difference? Good questions are specific, answerable, testable, and focused. Poor questions are vague, too broad, or impossible to test. Now let's talk about hypothesis. A hypothesis is a testable prediction about the outcome of a scientific investigation. Notice I said testable prediction. That's important. A hypothesis is not just a guess, it is a prediction based on existing knowledge. For example, if you already know that plants need sunlight to grow, then you can predict that plants receiving more sunlight will grow taller. That is a hypothesis based on existing knowledge. If you just guessed that plants receiving more sunlight will grow shorter, that wouldn't be a good hypothesis because it is not based on existing knowledge. A good hypothesis is specific, testable, and expressed as an if then statement. The if part is your independent variable. That is what you are changing. The then part is your dependent variable. That is what you expect to happen. For example, if plants receive more sunlight, then they will grow taller. The if part is the independent variable, that is the sunlight. The then part is the dependent variable, the plant height. This format makes it clear what you are testing and what you expect to happen. It also makes it easy to design your experiment. You know exactly what to change and what to measure. Let me give you more examples. If water is warmer, then sugar will dissolve faster. The if part is temperature. The then part is dissolving speed. Another example, if exercise duration increases, then heart rate will increase. The if part is exercise duration. The then part is heart rate. Another example, if soil has more sand, then water will drain faster. The if part is the sand content. The then part is drainage speed. Do you see the pattern? Each hypothesis makes a prediction about what will happen when you change one variable. Each hypothesis is based on existing knowledge. Each hypothesis can be tested through experimentation. You might be wondering, why should I use the if-then format? Why not just write any hypothesis in any different way? Well, the if-then format has several important advantages. First, it makes the cause and effect relationship clear. The if part is the cause, that is what you are changing. The then part is the effect, what you expect to happen as a result. This clarity helps you understand what you are investigating. Second, it makes the hypothesis testable. When you write your hypothesis in the if-then format, you can clearly see what you need to test. You need to change the if part and measure the then part. Third, it makes it easy to identify variables. The if part is your independent variable. The then part is your dependent variable. You can immediately see what you need to control and what you need to measure. Fourth, it makes it easy to design the experiment. Once you know your independent and dependent variables, you can design an experiment to test your hypothesis. You know exactly what to change and what to measure. So, the if-then format is not just a fancy way of writing. It is a practical tool that helps you think clearly about your hypothesis and design a good experiment. When you use this format, you know exactly what to change and what to measure. I want to make sure you understand the difference between a hypothesis and a guess. This is really important. A hypothesis is based on existing knowledge. You know something already, and you use that knowledge to make a prediction. For example, if you know that plants need sunlight to grow, you can hypothesize that plants receiving more sunlight will grow taller. A guess is not based on existing knowledge. You just randomly think something might happen. For example, if you guess that plants receiving more sunlight will grow shorter, that is not based on any knowledge you have. A hypothesis is testable through experimentation. You can design an experiment to test it. A guess might not be testable. A hypothesis is specific and clear. You know exactly what you are predicting. A guess might be vague or unclear. A hypothesis can be supported or rejected by data. If your data shows that plants receiving more sunlight do grow taller, your hypothesis is supported. If your data shows that plants receiving more sunlight don't grow taller, your hypothesis is rejected. A guess doesn't have this kind of structure. The key difference is this: a hypothesis is an educated prediction. It is based on what you already know. A guess is just a random idea. It is not based on evidence. In science, we use hypotheses, not guesses. When you design a scientific project, you need to make sure your hypothesis is based on existing knowledge. You might get this knowledge from reading, from previous experiments, or from observations you have made, but it needs to be based on something. That makes it a hypothesis instead of a guess. Now let's practice writing research questions. I'm going to give you some topic ideas, and I want you to try writing a good research question for one of them. Here are some topic ideas: plant growth, dissolving, sound, heart rate, water drainage. Choose one topic that interests you. Then write a good research question using the format does, how, what, that is the independent variable, affect the dependent variable. So let me give you an example. If your topic is plant growth, you might write, does the amount of water affect plant growth? This is a good research question because it starts with does. It includes the independent variable, that is the amount of water. It includes the dependent variable, that is the plant growth. It is specific, answerable, testable, with available resources, and not too broad or too narrow. Now it's your turn. Choose a topic. Think about what you want to investigate. Write a research question. Make sure it follows the format. Make sure it's specific, answerable, testable, and focused. Take a few minutes to do this. If you are watching this with a partner or in a group, you can discuss your questions with each other. See if your questions are good questions. Do they meet all the criteria? Are they specific? Are they answerable? Are they testable? Are they focused? This is an important skill, and the more you practice, the better you get at it. Let's summarize what we have learned in this lesson. Good research questions are specific, answerable, testable, and focused. They start with does, how, or what. They include the independent variable and the dependent variable. A hypothesis is a testable prediction based on existing knowledge. It is not just a guess. The if-then format helps you write clear hypotheses. It makes the cause and effect relationship clear. It makes it easy to identify variables. It makes it easy to design an experiment. A hypothesis is different from a guess. A hypothesis is based on existing knowledge and can be tested. A guess is just a random idea. Now, before we move on to Lesson 3 of Focal Area 2, I want you to think about these reflection questions. First, what makes a research question good? Think about the four characteristics we discussed. Second, why is it important to base your hypothesis on existing knowledge? What would happen if you didn't? Third, can you write a hypothesis for a research question you are interested in? Try using the if-then format. In Lesson 3 of Focal Area 2, we will learn about variables and how to design experiments. We will see how the research question and hypothesis guide the rest of your project. So get ready for Lesson 3 of Focal Area 2.